So I'm Nick Lilly. I'm a marketing manager at the University of Chicago Press. Thank you so much to everyone for joining us today. A few housekeeping things before we start. If you could please remain muted during the conversation, that would be great. Please feel free to put questions into the chat though, and we will return to them at the end of the hour. And I will very quickly introduce our guests because I am not the main show here. So we are here to talk about Jack Ashby's new book, Platypus Matters, The Extraordinary Story of Australian Mammals. So Jack is the Assistant Director at the University Museum of Zoology at Cambridge and an Honorary Research Fellow in the Department of Science and Technology Studies at the University College London. He is also the author of Animal Kingdom, A Natural History in 100 Objects, and lives in Hertfordshire. You can also find Jack on Twitter at Jack D. Ashby. He is an official blue check, so, and a lot of fun. Erica McAlister will be talking to him today. She is a senior curator of flies at the Natural History Museum in London, former president of the Amateur Entomologist Society, and an honorary fellow of the Royal Entomology Society. She's a radio presenter and the author of The Secret Life of Flies, The Inside Out Flies, and A Bug's World. McAlister is also a great tweeter, and you can find her at Flygirl NHM. I'm going to put a link to the Seminary Co-op's book page for Platypus Matters. We partner with them on our Buy Book events. So if you guys want to purchase a copy, if you have not already, please do so there. And without any further ado, I'm going to turn it over to Jack and Erica.
Hi.
Everyone.
Hello. So hello, welcome to my home. This is the Natural History Museum in London, where Jack has actually spent quite a bit of time as well. But I just thought I would introduce by saying, why am I interviewing Jack? Because obviously I look at flies and Jack doesn't. I have gone through this book. There is one mention of flies. But Jack and I have been good friends for enough time. And one thing Jack and I do is we like to pair up and go around other people's museums to look at both their public displays plus their collections behind the scenes. And there's been several moments in this book where Jack has come across the most amazing specimens, and he hasn't told me.
I definitely have told
I
you.
just can't believe it. They're not. I'm not in there anyway. But yes, so we have spent a lot of time chatting and probably arguing. Yeah.
I think actually, mainly, it's very complimentary. She'll say, look at these amazing insects, and I'll say, look at these amazing mammals, and we learn from each other.
Yes. But we will talk about museums and their collections in a bit. But one thing, and I've got a little present for Jack to start, which I was genuinely quite pleased about because I read the book and I quite like them. So here, this is your little present.
Thank you. This is very exciting.
You have to show people.
It appears to be a platypus-shaped tea strainer. So platypuses obviously have taken over the world and should be on more products. Tea strainers is obviously the next part of platypus world domination. I like it. Thank you.
Thank you. It's genuinely exciting when I came across that. So, Jack, platypus. Platypus is platypi, not. But tell me about. Go on, tell me why you love these beasties so much.
Platypuses, I think, for me, are the best. This is obviously a subjective opinion, but the best species to have ever evolved. They are kind of evolutionary biologist's dream. They show a range of features that have evolved over time in quite an incredible order. They show that evolution works by taking it's from a starting point. It can only work with what it got and kind of adding and subtracting from there. But genuinely, they're amazing. They are one of the only mammals that can detect electricity, one of the only venomous mammals. They are one of the only mammals that lay eggs. There are so many things. Their hands do incredible things. Where do you want to start?
Wow. So, okay, platypusology. Okay, the science of platypuses, which you've made that name up.
Well, all words are made up, aren't they? But, and actually, platypusology. So platypus is a word in Greek that means flat foot. So platypusology, like most ologies, is entirely made of Greek. Unlike most ologies, I mean. So I'd say it's more valid ology than.
So go on then. Tell me first off the feet. What is it about the feet? I have to say, I find the feet quite attractive.
Their hands are. I like to describe them as Swiss Army knives or transformers. What they do? Platypuses amazing because they live over 3 different modes of life. So they live in water, they swim really well, they live on land, and they burrow. And their hands, like I say, are Swiss Army knives that can flip out different tools to do different things. So in the water, when their hands are outstretched, they have a webbing that they can flip out that actually goes beyond their fingers. So they've got really long fingernails, and the unlike a duck's web where the web's attached to the foot,
Yeah.
or attached to the toes, in a platypus it's only attached to here, and then it furls out like, I guess, like an umbrella struts, but not attached. They then are supported by the fingernails and the fingers, and when they swim forward, obviously that falls out and gives them push. But incredibly, when they move their hands forward, because it's not attached, the web just collapses down. So it's like the most efficient web foot. So they can do that. And then on land, they fold that webbing up and they walk on their knuckles.
How do they keep it up?
So it's got their fingernails are long.
Really, well, I've seen them.
So when they push back, the webbing is pushed.
No, but when they're walking.
So they
they
bunch up their hands like a fist, and they're holding their webs in their hands. So they walk on their knuckles, and then when they're digging, they just fold back the web, and they've got this really long claws. And a platypus, which are, female platypus is about 50 centimeters. They can dig for up to good ideas, say 30 meters, but
So
more often
one of the stories you mentioned in the book, which again is the whole digging of burrows, was it the wombat burrow that boy kept digging through to find out what was going on? I mean, I'm guessing you can't do this with a platypus.
Well, no, because platypus is
exactly.
The best scientific description of a wombat burrow was done by a 15-year-old boy called Peter Nicholson.
I love this story. It made me giggle a lot.
And he was at boarding school in Australia, and he would sneak out from his boarding house every night, or I don't know, often, didn't tell anyone where he was going, and he would go into the woods and climb into a wombat burrow. Now, wombat burrows are about this big, so not much bigger than a 15-year-old boy's shoulders. Do not try this at home. And pegged out the map of a wombat, and he carried a little tin shield in case he came across a wombat, which are quite, blocky animals.
I grew up as a caver. I've spent a lot of time caving, right? Now, the idea of just going completely blind, as it were, down into this burrow system, which you've got no clue what it is about, and the fact he mapped them is extraordinary.
He wrote the story up in his school newspaper,
No.
and it's still like the most widely cited study of wombat burrows.
So back to the platypus. Okay, so they're really good at burrowing. A lot of them are really good at burrowing. What else makes a platypus amazing?
So they are the only seasonally venomous animal known.
Okay, so that did freak me out because I work with a lot of venomous creatures. A lot of flies are venomous. And the idea of being able to turn off and on your venom. Okay, you can have that one.
So yeah, venom is an expensive thing to make, like, energetically expensive. So platypuses use it like, I guess, deer antlers. So they use it for fighting between males. So they only need to do that in the start of the breeding season when they're fighting over females. So they only develop their venom during the breeding season. And then they grow, just to say a bit about them, they grow on like 2 centimeter, 1 inch long. It comes out of these spurs on their ankles. So they've got these horny spurs with a venom gland attached, which when their feet kind of point a little bit backwards. So when they're jabbing something, they just jab these spurs into something. And for a human, there are a few humans that have reported being stabbed by a venomous platypus. And it's one of the most painful things. The venom can last like 15 years. People have described still having effects from the venom. And it's like a cocktail of 20 different animal venoms. So they've got proteins that are the same as venom in centipedes, in snakes, in spiders, in anemones, in fishes, poison in frogs.
And are we using this in medicine? Are we starting to like?
Yeah, because it's so strange that it lasts so long, and people have like muscle wastage for decades. Like people are looking at different ways to understand pain pathways. So they're very handy creatures.
And so what happens after the season? Does this little horny thing just fall off?
No, the horn stays there, but the venom gland stops producing venom. Yeah.
Okay, it doesn't shrivel up. It just.
I think the gland will shrink, but the horny, it's got bone inside it, and it's covered with horn, so it just stays there.
It doesn't shed, and each year gets a massive one.
No.
That'd be great. Walking around like. Okay, what about the mouth?
So the mouth, like teeth, I'm sure everyone will agree, teeth are a terrible evolutionary adaptation. Like, obviously they're sensible for biting hard things, but they can, when they go wrong, it's a real problem.
Mhm.
I'm sure we've all been to the dentist and
I've still got baby teeth. Yeah,
And then look
I
about
live.
you.
I know, I understand. Teeth are a nightmare.
So platypus ancestors had teeth, but they've evolutionarily realized that it's a terrible idea. And despite the fact that platypuses eat really hard food, so they eat crayfish and insect larvae and well, sometimes snails and also worms, which obviously aren't very hard, but they also forage in sandy sediment at the bottom of lakes and rivers. So when they're chewing, if they had teeth, that would just get ground down constantly.
Yeah.
Animals that eat soil often die of starvation because their teeth wear down. What platypus have done, get rid of them and replace them with these horny, ridged pads. So horn, like made of keratin, so it's the same as fingernails and hair. So it can regrow constantly just out of the gum. So they're constantly wearing it down, constantly replacing it. It's smart.
I mean, that's well, the one thing I really loved as well, because I don't do mammals. And so this is why it's been quite interesting reading this book for me. I hadn't registered about like the teeth of the kangaroos when you talk about all the other animals, that they only have like the same, they have the same like 2 sets of teeth, but they only have a couple at a time. That was genuinely like, I remember just going to my friends at the time, like, oh, I had no idea. And that's what's been really fun about this book, is that it's just led on to so many me go, oh, wow.
So yeah, kangaroos have come up with a different solution to the teeth problem, and that's they've taken what we've got. So yeah, 2 sets of teeth in most species, and then but they only use 2 at a time, or 1 or 2 at a time. So they're moving forward along their jaw. So the elephants do something similar. But they can, each tooth will eventually wear out and fall out, but there's another one coming along behind it. So they've still only got the same number of molars as most other relatives of them. And actually, there's one species, the narbalek, which is a tiny, tiny rock wallaby, which seems to have an indefinite number of teeth, like a shark. So they've continually replacing these teeth.
Why don't we?
I know, like
No sense.
so many humans must. I guess the answer to that question. I was going to say, so many humans have probably died of starvation because of their teeth, but it probably happens at a point in their lives after they've reproduced, mainly. So it's going to have not much of an evolutionary pressure to fix it. But you know, most of us, I think it's fair that our ancestors had done what platypus did.
Yeah. I just like the idea of just regrowing all the time. I like to eat, and it just makes a lot of sense. I like their diet. I think that's a lovely diet.
Crayfish and worms.
Yeah. Oh no, crayfish, snails. I think that sounds really nice. You know, but and the fur as well. Their fur is quite amazing because of their habitat.
So yeah, they like platypuses live all over the east coast of Australia, so and down into Tasmania. So from the tropical wet tropics of Queensland, northern Queensland, down into Tasmania, where the lakes partially freeze over in winter. But they can spend like 25 hours foraging or more. But what's amazing is in water,
in one go.
Yeah, non-stop, 25 hours, more often 15, or even less, but they can do it without their skin getting wet. But their fur is so dense that it traps a layer, it keeps the water out essentially in their skin. If they're in good condition, their skin will stay dry. So even in that cold water, they don't get,
How do they cool down then? How do they do?
How do they cool down? I don't know.
I mean, it's hot some of the time.
Some of the time, and platypuses are really sensitive to heat, so they can't live above a certain temperature. However, being a burrowing mammal is, it's more. Underground is more steady, and also obviously being in water, that's going to be. I imagine they just go in the water. That's probably the answer.
I know, but it's going to be climate change. I imagine is going to have quite a nasty impact on them.
Absolutely, the effect of changing temperature is expected to impact on platypus distribution.
Have they got much of a fat layer, or are they underneath?
Yeah, they
can
store. They can be quite chubby, and they store, like, you can tell how healthy a platypus is because it stores fat in its tail. So quite a lot of Australian mammals do this. So you can judge their kind of how much they've been feeding.
Okay.
In addition, by how fatty their tails are.
And obviously, let's talk about what a platypus is. It's a monitory. So the most amazing thing about them maybe is their reproduction and their. So do you want to go into that?
Sure. So monotremes are the egg-laying mammals. And that is today just the platypus and 4 species of echidna. And echidnas are spiny, ant-eating relatives of the platypus, also from Australia and New Guinea.
I do like them a lot.
Echidnas are
They're very cute.
yeah, they're stunning animals.
Didn't use that word very.
Well, they are cute.
Yeah, they are.
True. But the fact that some mammals can lay eggs was like one of the most contentious stories in Victorian science and in 19th century science.
For vertebrate scientists, I'm just going to leave it there.
Yeah, for vertebrate scientists, but it was so important because when platypuses and echidnas were first encountered by Europeans in the 1790s, obviously, well not obviously, but people assumed that a defining feature of mammals was that they give birth to live young. And there was some suggestion that these 2 newly found species in Australia did something different. But it took nearly 90 years to prove that it was actually the case, that they do lay eggs. And the reason that's so contentious is because a number of people suggested that it was impossible for a mammal to lay eggs, and I think for quite political reasons. And one of them, we're in the Natural History Museum in London now. The main person that was fighting the charge against egg laying was the first director, first superintendent of the Natural History Museum, Richard Owen, who Erica.
I will carry on this a little bit because I feel that I have more right to, because he's my museum forefather and the reason this museum here. He is described as a lugubrious character, and that is a polite way of saying it. As a female scientist, my feelings towards him are quite mixed as well. He was argumentative. The classic fight with Darwin is the one we all talk about. And I will say there used to be a statue of Adam on the top of the museum, which fell off. And we've always wondered, did it fall off? And now in the main hall, which sadly you can't see behind over there, the main character in the hall is Charles Darwin. And the statue of Richard Owen has been moved. It's almost been hidden. And he's clutching a mower bone. And it looks like he's about to run around the corner and smack Darwin. So this is the character of Richard Owen. So you carry on with the platypus.
Owen was the main person fighting against Darwin.
And everyone.
And everyone. He kind of destroyed people's careers. He was Machiavellian, supposedly stole specimens of people, but did good things like found the Naturalist Museum, described mowers, the giant New Zealand birds for the first time in science, and also described a load of massive Australian extinct species. However, he also led the charge against the idea that platypuses could lay eggs. And the reason I think is that he was, one of the reasons Adam was on the building is that he was, a very religious man.
Deeply.
And I think that he thought it was morally wrong for something that was clearly a mammal. He believed they were mammals, they've got fur. He believed they produced milk, which was contentious, but he proved that they did. Something so obviously mammalian doing something so kind of something that pulled our great class down into the mud with reptiles and amphibians, which he would have considered morally problematic. But also the fact that a mammal could lay eggs is clearly evidence for evolution, because it's that we know that mammals evolved from species that looked a lot like reptiles.
Yeah.
And the reason platypuses and echidnas lay eggs is that the first mammals laid eggs, and platypuses and echidnas have never stopped laying eggs, unlike placental mammals and marsupials. I
mean, it has caused a lot of debate amongst my friends about which type of reproduction, as females, which we prefer. And I think basically they have got the better option. Eggs, quite small. Get them out there. That's fine. We weren't happy with the marsupials, with them climbing everywhere. We were like, no. And as for placentals, well, that's painful. So, I think I quite like to come back as a monotremes. I think that would be much more if I was coming back as a mammal and coming back.
You might want to choose a platypus specifically then, because echidnas have pouches.
Yeah, I know. That freaked me out a little bit.
And of course, echidnas are spiny. So as they grow, the babies grow in the pouch, the spines grow. And so at some point they have to leave. And I imagine one of the reasons why they leave the
The
pouch.
spines go through the pouch.
Don't go through the pouch, but they grow out
But-
of the baby's skin. So I imagine at some point they become.
Oh, see,
You've got
no.
a soft, skinny pouch.
Why is everything having to go at females? No. Oh, yes. So yes, and they lactate.
Platypuses in the echidnas lactate. Yeah.
Yeah.
So the defining feature of mammals is that they produce milk and that they have fur.
Some flies lactate.
Why don't you talk about flies?
Because this is what I love. It's like every time he says something, I'm like, oh my gosh, some flies do that. And there are these flies, they give birth to live young, and they have internal lactating glands without nipples. Well, they've got a little kind of nipple, but it's not a very pronounced nipple. And again, it's the same thing. It's a milk-like substance. They are lactating.
It's a milk, so
It is milk. Yeah. I mean, there's the cockroaches produce milk as well.
okay. No.
It's not going to be a superfood. It's not going to be something you can get in your coffee. Can you imagine? Yes.
But
I would like a skinny latte with cockroach milk, please. It's not produced in vast quantities, but it is exactly for the same reason. Really nutritious, really, really nutritious.
sensible thing.
Yeah.
And I joke about cockroach milk in coffee. Richard Owen is one of the only people I am aware of who's tasted platypus milk. And he, as I said, there was an argument about whether they're mammals at all because they don't have nipples. Platypuses and echidnas produce milk without nipples. So it kind of oozes onto the skin, and the babies lap it up from there. And there's some reasons why that's sensible, but I'll just say that Owen was trying to prove that they did produce milk because when they are not lactating, their milk ducts are tiny. When they are lactating, like they cover the whole belly and they go around onto the back. So the people before Owen were just seeing specimens that didn't have enlarged milk glands. But he took a specimen that had been shipped from Australia and in a jar. So it had been dead for at least a year. And then he squeezed the milk gland and tasted it. But what's interesting about the fact that they don't have nipples? Two things.
What did you see the audience reaction then? Seriously, I was reading this on a bus, and then suddenly I'm like, oh, that was unpleasant.
I have a general rule: you don't lick things in museums.
It's good to live by. Yes.
But he obviously didn't follow it. That may have happened when it wouldn't have been in this. Oh, it may have been in that building. Yeah.
Yeah, let's not think about that.
Which is pretty cool. But I will say about platypus milk and the not having nipples is interesting for two reasons. One is that I can't see how a platypus or an echidna could have evolved their bills if they had nipples, because you can't suckle with a beak.
Yeah.
So in order to suck a straw or a teat, you need to be able to form a seal at the front of your mouth and at the back of your mouth. So if you try breathing and sucking a straw at the same time, you can't do it.
And that's one of the things you say about the kangaroo, that the nipple keeps growing. It's like, oh my
Nipples
god,
keep growing.
keep
They
growing.
start off
Yeah.
this big and they finish off this big.
Mm.
So obviously,
Yeah.
the other thing I was going to say, platypus milk not having nipples is that nipples are a sterile delivery device. So the milk goes from inside the mother into the baby without ever being contaminated by the outside world. But that doesn't happen in platypuses because it leaches onto the skin, which has been in lakes and rivers and dragged along muddy floors. So platypus milk is being looked at because it has really strong antibacterial properties, which could be used to help things like antibiotic resistance in hospital superbugs. So again, platypus is saving the world.
Which again is parallel with the insects and with the flies.
Is it?
Because the maggots can live in really disgusting environments. So we're looking at their exoskeletons, whatever, to figure out how they do this. Plus they release enzymes to destroy MRSA. Honestly, we need to kind of get the flies and the platypus together. Ooh, a bit like this. But yeah, but you, how did you, and they are extraordinary. How on earth did you get into this? You're not from Australia.
Hardly no.
No. And you live quite, in a very different environment from the outback, Tasmania, etc. How did you?
I don't know if you'll see this. This isn't why it's in the book, but I was convinced of the amazingness of platypuses by actually this specimen here, which is in the University Museum of Zoology in Cambridge. And when I was an undergraduate a long time ago, we did our classes were 1 week at a time. We'd do one group, the next we're doing different groups every week of animals. And when we got to egg-laying mammals, my lecturer Aidan Friday pulled out this specimen and others and told us about them. It was just like, this is the most amazing species that has ever evolved. And it's also a really nice, just a freeze-dried platypus, which is really unusual.
Yeah, it's a shame because we've got what is they think to be the type here,
Which is the first specimen that was used in the description, scientific description.
and it doesn't look as cute as that
No.
one. It's most of the types don't really. They've gone through a lot to get where they are.
And they're not really mounted as taxidermy.
No.
They're mounted, it's the display, they're mounted for research.
So you saw these, you went, that's it, I'm done. I've lost my
That's
heart.
like top of, I must, every zoologist has like a
I have a
bucket
moment.
list. I'm gonna say, has a bucket list of like a species they want to see. And it's not like, check, next. It's, I want to see it. And once you've seen it, you want to see it again. But I was like, I have to see a live platypus. And they were acted as a gateway drug to the rest of Australian mammals.
I was very lucky. I was at university in Adelaide for a while, and I did get to explore around. Never saw a live platypus, but I do remember my first echidna, and it was in the Adelaide Hills, and I was with a load of Australians, so they're like, it's an echidna, and I'm like, and I was rather excited, and that's just an echidna. So when you saw, I know it's not just, but when you saw your first platypus,
what happened?
yeah, was it like watching Spurs win like 10?
It was amazing. Amazing. I was in Tasmania, and my friend Toby Nolan and I had been looking for a load of animals, and platypuses are kind of the last one. And we've been walking for a week along the mainland, massive long distance walk, the overland track through the Central Highlands of Tasmania, and it was stunning, but it was busy. Like there are other people staying at the same hut, so every night we get to the hut. I'm okay, right now let's go and find the nearest river or lake and sit down, because they can mainly come out at evening and dawn. Let's go out and sit and watch. Everyone else was there like swimming because it was the middle of the summer, so we didn't no chance. And then on the very last night, as we came into the rainforest, it'd actually been hot. Tasmania can go from sunny t-shirt weather to actual snow in hours, and it was the day before Christmas Eve, in the middle of summer, and it had been snowing the day before, and then it started raining, like proper rainforest rain, and we came down from the mountains into the rainforest, and it's temperate rainforest, so cold rainforest, and we're like, this is great because no one's going to be swimming tonight, let's go out. And I sat by a little burrow for a while, staring at this burrow by the water's edge, and Toby just wandered off down the river towards the biggest lake in Tasmania, in Australia, actually, deepest lake in Australia, Lake Sinclair. And after about an hour, I realized I couldn't see or hear him. So, like, if one of us saw an animal, then we'd know the way to communicate. And I got up and I followed his footsteps through the mud, and I could see him across the lake, and he was like, could see in his face that I'd seen one, and I'm absolutely terrified.
It's gutting to think you weren't going to see it.
Yeah, exactly. But I got over there, and there it was, and proper tears in the eyes. It was.
I have only ever seen them in wildlife centres. I mean, they are really cute, and they're quite small.
Yeah, Tasmanian one's about this big.
Okay.
And the Queensland one's about.
I've only seen Queensland ones then. I didn't see them in Tas. In Tas, I came across wombats.
Wombats are the second greatest species in the world.
I also saw a baby wombat, which looked like a pink hairless pig. It was I wasn't expecting that to turn into this creature that is a wombat. Do you want to give a little bit about the wombats then?
I certainly will. The wombats are about, I keep moving in the wrong direction, about 25 kilos, 30 kilos, and grazing, very short, very dumpy,
like me.
herbivorous marsupial. And I like platypuses for quite scientific reasons, I think. They do interesting things. The reason I like wombats is that I like animals that waddle. So
honestly, when I read this, one of the things I wrote was waddling, because Jack used waddling quite a bit by describing how they move, waddle, and it was not a word I'd used for quite a while. I think my grandmother loves the idea, and it was suddenly like Jack talking about these waddling creatures, and
they can go really fast, so they can when you're in remote in field work with very small numbers of people, but you don't see anyone else, you get into quite have some very strange conversations because you run out of things to say. In field work in Tasmania, a colleague and I, Rodrigo Hamid, said, there's a wombat running alongside the vehicle through the forest. Let's see how fast it can go. And it was tracking us at 30, 40 miles an hour.
Wow.
And we worked out that over short distances, wombats are faster than Usain Bolt. And that was our strange,
really?
Yeah,
Really?
strange back of the envelope conversation. But what I like about them is that they are very nonchalant most of the time, and then they'll just suddenly burst off in this bompity 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 bomb.
When we came across one, we walked straight up to it. It didn't register us there. You then registered us, and it stuck its head into the ground and just stood there. So we just stood there.
They're really solidly built, and they've got excellent defense mechanisms. So this is some more scientific reasons why to like them. Wombats have really solid backsides, really solid. Like they've got a bony plate and then a load of connective tissue.
I am so getting one of those.
And so what they do is if they're chased down, and let an animal chase it down a burrow, and then they'll simply smash the animal's head, like these days a dingo or a fox, against the roof of the burrows.
Yeah, you described this in the book of finding skeletons crushed. What a way to go!
I know.
I mean, that's
Don't chase a wombat down a burrow.
No.
Peter Nicholson was lucky.
That poor boy. Could you imagine if that would have been horrible? How embarrassing! Die by a wombat's bum.
Worst way to go.
Oh, maybe.
And the other thing people like about their bottoms is that they produce cubic poos.
Yes.
So
And finally, we've got to the end of this, haven't we?
it's been a big mystery how to produce a cube with an anus, because their anuses aren't square. And it's just a few years ago proven that what they have is they have alternating bands of flexible and stiff intestines, so that when you squeeze that, it produces corners. And this is not only interesting because wombats are interesting, but also because it's a novel way of producing a cube. So engineers might think about how to.
And there's a unique fly that feasts on wombat poo. Yeah.
Are they really slow? Because the benefit of wombat poos for a wombat is that they don't roll away, so that they use them as little markers for their territory. So if a
wombat poo is not exactly nutritious, so you're not going to get a lot of flies that will feed on feces. They can quickly go in there, lay eggs, get out of there. With wombat poo, it's much more
you see it in places that are dry that have wombats. You see the whole ground is just carpeted in these poos because they don't.
How many
drop.
photos have you got of wombat poo?
A lot of.
Yeah.
It's because it doesn't look like in dry part of the country. It doesn't rot. It's just everywhere.
Yeah, holiday photos with Jack. Here's some more wombat poo. Here's a bit more. Yeah, no, I've got a few of those. I like them. So you in the book, it's great. You talk about obviously the first love platypus, go on to echidnas. I love echidnas. You talk about evolution, but one of the things you do highlight is how we've got to where we are and how we understand where we're going on. And that's quite a hard read in some ways, because to get to level of our understanding, a lot of research had to go on. And some of the way this research was done is definitely something that causes me as a museum specialist and many people to wince slightly. Do you want to go into some of that?
Yeah, I mean, obviously, just to preface this by saying that mammal collecting today in science is extremely ethically controlled, and it's very, very rare to. And
it's done with the permissions of all the countries and everything like this. Nowadays, we definitely.
But not so much in the past. In fact, in the big debates over platypus reproduction, Richard Owen asked his main contact in Australia, the naturalist George Bennett, to kill a platypus every week during the breeding cycle so that he could find out whether they had eggs inside them. In the end, Bennett said was uncomfortable doing that. However, the person that actually did solve the mystery of egg laying to the satisfaction of European scientists was a Cambridge embryologist called William Caldwell. He was working with about 150 Waka Waka indigenous people in Queensland, and he or on his behalf, these Aboriginal Australians killed about 1,400 echidnas to eventually prove that they do lay eggs. And we don't know how many platypuses, but many.
Yeah.
And I normally would say that collecting for museums or collecting for science would never have an impact on our local population, but it is impossible to imagine how 1,400 echidnas could be taken out of a local area and it not have an effect. It's unlike, obviously, only the females have eggs, and most of them they caught a male.
I know.
We don't know what happened to the male. It's that's quite staggering.
It was quite staggering, and like they talk about as well. I mean, we should probably mention that thylacine, because that wasn't made extinct because of them trying to understand things. That was just
so thylacines are dog-shaped carnivorous marsupials, the largest carnivorous marsupial of modern era, and they looked a lot like dogs. If you were to see a dog and a thylacine stood by side, the only difference you'd spot is that thylacines have black stripes on them. This is amazing because they're separated by 160 million years of evolution. But thylacines were deliberately driven to extinction in Tasmania. They're also called Tasmanian tigers. Tasmania was invaded by Europeans in 1803, and by 1830 they established the first bounty on them. And the government shipped in another bounty in 1888, and by 1936, so just 106 years after that first bounty, the last known individual died. So they didn't go extinct in 1936. They probably went extinct. Best estimates now, they actually probably went extinct in the 1990s or early 2000s, which is amazing to think that in our lifetimes there were.
So you definitely think they're extinct?
I definitely think they're extinct. Many people don't. They're the most cited extinct animal in the world, and certainly, if they were alive until recent decades, then many of those sightings would have been real. But they were deliberately driven into extinction because they were accused of killing sheep, which we now know they didn't do.
No.
And in fact, it was more likely that the hunting dogs that European sheep farmers brought in to hunt kangaroo whilst their sheep industry was failing and they needed extra protein.
Yeah, I mean, there's so much pressure. So there was the original collecting zeal. So there was a lot of that, and on different animals to understand what was going on. But that only in a few of them had this huge impact. But then the European settlement came in that had a massive impact on these populations. And you talk about how many species of mammal have probably been lost.
So Australia is the mammal extinction capital of the world. So in that one country, about 37% of all mammals have gone extinct since European invasion, 1788. About 37% have gone extinct in Australia. And so that's about 35 species. And then pretty much, many of the surviving species have shrunk to a tiny fraction, like 1-2% of their former range. And that means that Australia's lost about 10% of its fauna itself. So there are 10% fewer mammals now than there were 250 years ago.
That's extraordinary. We were just looking before we came on air at quite a bizarre looking creature with funny feet.
Pig-footed bandicoot.
Yes, which obviously a taxidermy specimen is never going to show off its best light, but this is sadly was one of the species that went extinct.
Two of the species we now know, in fact,
exactly
from museum specimens, including in this museum. So the pig-footed bandicoot is a very famous species because it's the only marsupial to ever evolve hooves. Now, most marsupials have to climb physically, which is, I think, like the most amazing thing in biology is that a marsupial gives birth after days in the womb. So a bandicoot is about 10 days. So is a honey possum. So the smaller mammals, many of the smaller marsupials have like less than 2 weeks in the womb. And they give birth to these little jelly beans that have really well developed hands, really well developed lips. So they climb from the vaginas up to the pouch on their own. So the mother doesn't help them. And then they use their hands. They've got after just a few weeks, or even less, they've got the motor skill, the nervous control, and the sensory ability to find the teeth. But why this is interesting is that it means that most marsupials can't evolve away from hands. So a grasping hand is a fundamental, important It's more important than pretty much anything else
Yeah.
because they need to climb. Now, bandicoots are the only marsupial, or one of the only marsupials that don't climb. The mother furls over and flops the baby into the pouch. The pig-footed bandicoots, the only marsupials that have ever done anything vastly really different, and they've evolved hooves with their hands.
Yeah.
But unfortunately, because Europeans introduced cats and foxes and then cleared land for agriculture, pig-footed bandicoots went extinct in 1950. But just 3 years ago, we thought we'd lost one species of pig-footed bandicoot.
Yeah.
Turned out, looking at museum specimens, that there were actually 2 different forms, and we actually lost 2 species. So we were looking at one of those specimens that was used in that study, which is pretty.
I mean, we're seeing this a lot with museum collections now, because and this is the one thing where we have museum collections, is that we are able to go back, we're able to analyze, and we have new and novel techniques of looking at these specimens. And so we're able to get historic DNA out of them, we're able to do all of this. And it's really good, but in some cases.
Well, we keep finding, we lost more than we thought.
Yeah.
So there were one species, another group of bandicoots was changed from 1 lost species into 4 lost species.
Yeah.
So it's kind of, it doesn't change anything in the real world, they're all still gone, but it's, it means that we understand more about what we've lost.
There's another little mammal that you have a little soft spot for, that you describe in the book, is that the first time you saw it was in a wallaby's anus.
Oh yeah.
Yes, Jack.
So I do a lot of fieldwork with Tasmanian devils. And Tasmanian devils are famously scavenging marsupials. They're about size of, I've got that wrong every time, about the size of a badger or a bulldog. So a big one is big one. Well, bigger.
She's a big.
Yeah, so a big male devil is about 13 kilos. I don't know what that is in pounds, but American 26, no,
2.2 pounds.
Yeah, so about 30.
Yeah.
The first time I saw one, it was chewing its way into a wallaby through the back end.
Pleasant.
Yeah, but they can strip a carcass for literally nothing. They'll eat the whole thing. They've got the most powerful jaws any living mammal. They're absolutely amazing creatures.
And they're not that nasty or not that vicious, are they?
I mean, they're famous for being super aggressive.
Yes.
And they are very aggressive towards each other, which is unfortunate. The reason I go to Tasmania to do fieldwork for the University of Tasmania is that they are sadly suffering from a contagious tumour, devil facial tumour disease. And that's when it's a fatal cancer. When one devil bites another devil, the cancer cells can stick to the second devil and start growing a new tumour. Absolutely makes the cell itself, the cancer cell itself, is the pathogen. It's not a virus, not bacteria.
Weird.
It's incredible. But because devils do bite each other a lot, then that's how the cancer is spread. But they are the most placid animal I've ever worked with. When you handle them, they just go floppy. But of course, as they have, we are in their mouths, we're looking for the tumours around the mouth. So we really don't take any chances.
No, so we're coming to the end of time before questions, you see. So that the devils aren't, but there's this picture in the book of this little creature here. This one. How big is that one?
So that's about 2 grams.
It's always the little thing. Never trust little things.
That's a long-tailed planigale, which is the smallest species of marsupial. It can honestly, we trap them in these buckets, these pitfall buckets, where you dig a hole into the ground, you put a pipe in it, you run a plastic fence along the top, and then when the animal walks around at night, hits the fence, walks along the fence, and then drops into the bucket. If a blade of grass falls into your pitfall trap, and I've seen planigales, like, they're so small they can climb a blade of grass, but they are, as you say, the most ferocious animals. They will, like, as the carnivorous marsupials get smaller from placid devils,
So do they make it
about 70
they're
other
just
species,
angry?
they've just got so much chutzpah. They will try and take your face off, but of course, because their teeth are less than a millimeter long.
Can they pierce the skin?
No.
No. So they've got small mammal syndrome. Is that what you're
Yeah,
saying?
small mammal syndrome.
And then there's so you get this picture, and then you get, right, I will lose all my professional credibility right now because I talk about how annoying mammals are and I have no heart and whatever. But Jack has this picture of this, just look at it. Just look at its feet. Look at that Go on then, explain this ridiculous.
It's a sad truth that most people work on mammals because they are cute. This is a honey possum. Sorry, a pygmy possum. So most famous possums in Australia, the ones that kind of live in people's back gardens or their roofs.
Yes.
Brush-tail possum is this sort of size, quite a chunky beast. The pygmy possum, when you sort of fit in the palm of your hand. And what's like that picture was taken while we were trying to take do a study for Kangaroo Island debunks, which are one of the rarest mammals on Earth. They only live in a few parts of Kangaroo Island. And so we were trying to find new sites where they lived. And all we were catching is these pygmy possums, which like it's impossible to be disappointed. You look into the trap and there's no debunk in there every time. You know, you spend days digging holes in the ground.
But they put these real
and then you just they've gone in, like they go into torpor overnight. So you pick them up and they've shrunk down, and you like they've got massive ears, but they fold them down over their heads. And they've got long tails, but they curl them up.
It's
like
really
a rope, a rope on a boat. And like they're very sweet.
They are.
So it's impossible to get disappointed when you catch one.
And it was really annoying because again, I was like, damn, Jack, you're making me just go.
For the record, Erica regularly describes flies as cute.
Yeah, yeah, I do. But they are. So you just pay attention. But yeah, so that's basically some of this tiny bit. We had thousands of questions to ask each other and talk about the history, the colonial, I can't even say it now, colonization, how it impacted, and all the other species. I was quite interested as well because you talked about the placentals, so the bats and the rodents, and how they also, you know, we don't pay much attention to them, which is a shame. It's just a few of these big mammals that seems to take all the limelight the whole time when there's so much more fun going on, and it's all the fun is happening in Australia.
Best place for mammals in the world.
Yeah. So, does anyone have any questions? You can all come along and talk now.
Oh, Nick, we can't hear you.
We can't hear you, Nick.
Sorry about that. You can put questions in the chat, or it's a small enough group. I think that folks could unmute if you wanted to actually speak.
Joseph.
Hi, thank you so much for that. It was really fun. I wondered if you, Jack, I wondered if you could tell me a little bit about how much they eat. I remember you've talked about what they eat, but one of the things I was shocked to learn from this book was just how much they eat. So could you tell us about that?
Absolutely, yeah. So platypuses are extraordinarily successful hunters. They can eat almost their entire body weight in insect larvae and worms every day.
Yeah.
So like they can catch hundreds of worms and crayfish. And what I didn't say is how they catch them, which is pretty much unheard of in mammals. Sharks can do it, but in mammals it's pretty much heard of. Don't know if any insects can do it. I know, well, actually I do know that some insects can detect electricity, but platypuses can detect electricity with their bills. So when they dive, so they hunt underwater, and they've got these little muscular grooves in their heads, in which their ears and their eyes sit. So the only animals known to pair their ears and their eyes in this way. Underwater, they squeeze these grooves shut, so they can't use their ears and their eyes. So it's a complete mystery for almost 200 years how they ate so much food. It was proved in the 1980s, and then, well, it's found in the 1980s, proved in the 1990s. Well, what they do is, with their eyes and ears closed, they can sense the world in electrical impulses. As we were taught in biology class, every singular muscular contraction in the animal kingdom is controlled by nervous impulses, by electrical impulses running down the nerves, including our heartbeats. So platypuses can sense all of these heartbeats and other muscular contractions of worms and crayfish and insect larvae under the sediment. So they've got they, as I say, can eat their almost entire body, which if you're a platypus this big, that is a lot of tiny little bloodworms. And that is the main reason why they are almost impossible to keep in captivity, because they require so much food. And in fact, like in the earliest captive populations, the entire communities were like, there was an economy around worm catching, that people were bought their own horse and buggies by selling worms to the zoo. Like they would sell them 6p a tin and that was, you know, to buy a horse and buggy, that's a lot of worms. Yeah.
I'm just trying to think of whether we can get some insects. I'm going to get back to you on this.
Insects that detect electricity.
Yeah, I mean, I know they do.
Bees can detect.
Yeah, I know ants do. So Hymenoptera is a definite. I'm going to have to just, well, flies have to, because I can't believe they don't. But also, you can get Australian earthworms that are about 2 meters long.
Yeah, I mean, that's,
Come
that
on.
would be,
That would be
didn't have to
surely.
catch anything else.
No, the big platypus and that. Oh my, best day ever.
Yeah.
Yeah, but that's a lot of worms to catch.
There's a lot of worms.
Yeah, you're making me
With your
hungry
iPad.
with the worm conversation. Any more?
I mean, I have a question. I mean, one thing that you've hinted at is how sort of the perception of Australia influences how we think about the animals. And that continues now still. And so I was wondering if you could talk a bit about that.
Yeah, I'm pleased you asked it, because that is like, that's one of the main themes of the book is that throughout their descriptions of descriptions of Australian mammals over the last 200 years, they are consistently described as kind of inferior, lesser mammals, that they are somehow lower down the evolutionary chain compared to placental mammals like us. And that is important because I think it's really influenced how we consider them today. So go to any naturalist museum, including this one, go to any newspaper article about platypuses, go to any TV show about Australian mammals, and the overriding trope is weird and wonderful. You know, these animals are kind of bizarre evolutionary curiosities, and that also that they are primitive. Now, no living species can be primitive. That is scientifically impossible. But it's all down to this colonial framing, I think, of 200 years of them being painted as inferior. And that, I think, is important, not just because we shouldn't put value judgments on animals, at least we shouldn't put negative value judgments on animals. But it's important because, as I say, it's got the worst extinction rate in the world. So we only protect what we value. And describing something as an evolutionary oddity suggests that they are, or primitive, suggests that they're
It's not the oddity, it's the primitive.
Well, I think it's
because the oddity is still something that's very much loved by people, and they've overhunted oddities.
But it's still a value judgment, and I think it doesn't help saying if you're placing a decision between let's clear this forest for agriculture versus all these cute little weird possums.
Yeah,
I think like that doesn't help that balance. But the primitive thing is that it suggests that they're evolutionary determined to go extinct.
yeah,
And that was kind of levied against them throughout their descriptions, that it's a shame that they're going, but Europeans have turned up now and everything we've done is better than what they've done. But obviously if you cut down a koala's tree and then blame it for going extinct, that's ridiculous.
No, and it's interesting because we often discuss language. We think language is very important and how we describe everything. And as somebody who studies things that not many people like, and they're called creepy crawlies, and they're called mini beasts. And already so you put creep and crawly in a term, and you've done this, and it's exactly the same thing. Without realizing it, you've given biased before you've even told about how wonderful this creature is and what the amazing things about them. You do that, and it's interesting because he has made me think more about the language and more about how we deal with it in collections. And you just see this legacy all the time, and it's being dealt with now. It is definitely, we're trying to be.
But it's so easy to do. Like
BBC
will say, Australia has been isolated for millions of years, and it's got these weird and wonderful. And like it's supposed to be celebratory. Obviously, wonderful is better than just weird, but it suggests that they are completely removed. Australia was never isolated. It's like most of the world's birds flew out of Australia, and obviously they had the advantage to fly. Like Australia was the center of evolution for birds. Australia's been connected to South America and Antarctica for tens of millions of years. That's how everything got there. This narrative is kind of there's this evolutionary backwater down there doing its own thing. Is all a colonial framing that's kind of prioritizing the northern hemisphere.
Exactly. So yes, very interesting. Plus, you were talking about females and how the names of the females
Yeah.
in the book. Yeah, I picked up on that already.
I think it's unusual that probably flies are a good example of species that do this as well. But that most animals aren't described after they aren't named for female anatomy, whereas marsupials absolutely are. So marsupial means pouch, and that's talking about the female's anatomy. Obviously, only females, nearly even male thylacines have pouches, but that's a rare.
Do they look after? Did they look after the young as well?
No, they kept their balls in their pouch.
Gosh,
But like so many scientific names of marsupials have a word for pouch in it. So thyla, para,
yeah.
and there's another one. Anyway, I think that's quite unusual.
I think it is unusual. We have several families that their genitalia, the female genitalia, her ovipositor is unique, so we could do it on that. But most of the time, it's on male genitals.
Yeah.
Yeah. So it's quite, yeah, it's quite interesting that.
Yeah. Obviously, that is like the thing that was considered remarkable about them is how they reproduce.
And actually, your description of the echidnas, the first time they described echidnas reproducing, well, I still made me giggle because I sat there trying to be two echidnas because you were saying that they do it like that, which makes sense. Or they do it like, is it?
So,
but it's the way.
I don't know if you
Have you read the?
I don't know if this is a similar joke in the US for porcupines, but in the UK, our joke is, how do hedgehogs reproduce? And
Carefully.
Carefully. There's a real mystery how echidnas, which are also spiny, reproduce. And one early account was, or 1927, not that early, was it was suggested that they go belly to belly. Like stand up on their back legs and go belly to belly.
Mating face to face on their hind legs.
Yeah, it's described as like a spiny, when they're joined together, it's like a spiny pumpkin with the stalk sticking out, and the stalk is their tubing. But actually, we now know that the males dig a little divot underneath the female and position himself underneath the female's back end with his arms over her back. That's how, still quite careful.
Are we going to end on that?
Yeah, maybe that's the perfect thing.
Oh. Is there any more questions? One more. Go for it. Anyone? Oh, you're so nicely well behaved.
maybe echidna reproduction is the best place.
No, and we're not that well behaved, Eric. Come on. I wanted to ask your enthusiasm for your subject. It's very infectious. It's very like Erica's enthusiasm for flies, and I can see that she's a wee bit kind of keen on what you've been researching. So she's getting, just a wee bit of keenness. I just wondered if you were getting very keen on flies at the same time.
Absolutely, certainly by Erica's book, Inside Out of Flies and Secret Life of Flies.
What was the bit you described in it? You were like, oh, Erica. There was one bit. I think it was about the genitalia as well.
Yeah, absolutely. When I go around, I go around naturalist museums around the world, rarely without Erica, but when I am without Erica, my first, in the insect section is, where are the flies? Because universally, it's all butterflies and bees and beetles.
So I feel like definitely with the monitoring, he's got the flies of the insect world. It's like, it's always, he still get 1 or 2 specimens per museum. I don't.
Yeah.
And it's like a pair of us, I think, are trying to do this crusade to get zoology proper, more representative of actually what's going on.
Completely representative, then the museum displays would be 80%.
It would just be all flies.
And nobody wants 80% beetles.
We're waiting to fly. Yeah.
Yeah, she had maybe, and she will make anyone appreciate flies if you read her books too.
But it's really nice because I think it's very good. Because there's so much crossover, and this is what's really good, is that if you do a zoology degree or something like this, you have so little chance to study so many things. And so we just learn off each other, and there's so many things you're like, hold on, these do that, that do that. And so my insects are obviously that big, but they're doing exactly the same thing as your monotremes doing that big. And that's lovely to see. You the whole environment comes alive at that point.
Well, you're the best people to make zoology a bigger thing, definitely.
Oh,
we need someone from the BBC to say that. That'd be lovely. Oh, we
It
don't mind
would.
if you do it in America, it's fine as well, that'd be great. Or Australia,
Yeah.
or anywhere really. Okay, so I think it's time for me to say thank you and goodbye and
Thank you.
Thank you.
And thank you for coming.
buy the book. It's fabulous. Look, mine is completely battered because of the amount of reading. So thank you very much.
No, thank everyone for coming in. Thanks to both of you. This has been wonderful. And if cockroach milk lattes become a thing, I will try one, maybe.
Okay, I'll just call you Richard Owen.
Yes. All right. Thanks all.
Thanks a
Bye.
lot.
Thank you. Bye bye.